Okay, so today we'll discuss about the application of Kirchhoff law. We'll use the Kirchhoff law and we'll solve this example 3.8. So here you can see one 10-volt cell is connected to this western bridge. There are four resistors here, 100 ohm, 10 ohm, 5 ohm and 60 ohm. Now you see the current I is flowing in the main circuit, which you will come up to a, and here you can see there are two conductor, or you can say this junction is there at A. So at this junction the output current, let's say, will be I1 and I2. They will be, means the main current I will be divided into two parts, I1 and I2. Now at B again there will be current division. You know from the Kirchhoff's law that the current gets divided, or the sum of input current must be equal to the sum of output current. So that's why the current I1, which will flow up to B, will get divided into two parts, will get divided, and let's say the current will flow Ig amount through this conductor, that is BD. So in BD a current detector like galvanometer is connected, and this resistance of this BD, let's say it's 15 ohm. So I1 is the incoming current, Ig is the output current through one branch. What will be the current through BC? So obviously, as the total is I1, so in one branch Ig is flowing, so in the next branch the current I1 minus Ig will flow. I1 minus Ig will flow. Similarly here from A, I2 is flowing, but Ig will come and meet I2 here. That's why two input current Ig and I2 both are input current at the junction D. So the net output current will be I2 plus Ig. Net output here will be, it will be I2 plus Ig. Now you can see at junction C all the currents will add up, and the same current, that is incoming I, same current will flow here at C also, means I will be output. Now we'll use the Kirchhoff's loop rule to these different branch, different loops, and we'll solve the unknown quantities, that is I1, I2 and Ig. So the question you can see here, but a galvanometer 15 ohm resistance connected across BT. Calculate the current through the galvanometer when the potential difference is 10 volt maintained across AC. That means in this question what is asked, only asked the, it is asked to calculate Ig, but you can calculate I1, I2 also. So how will you calculate Ig? As you know, there are three variables, so at least we require three loops, so that we will get three equations. From these three equations we can calculate I1, I2 and Ig. So you can see three loops here. We'll use loop law. So here you can see three loops here. Okay, so you can see three loops here. One loop is this one, that will name it ABDA. The second loop is BCDB, this loop, and the third loop will take, that is ADCEA, this loop, this loop. So three loops, from these three loops we will write three equations. So you know how to use the Kirchhoff's loop law in using the voltage and current combination. So how will you write? So I used to write in this way, that is, I think I feel convenient. That is, when I move along with the direction of current, I write there is a potential drop, so I write negative. When I get a resistor current in opposite direction, I write plus. So in that way I'll write. So for the loop, that is ABDA, for the loop ABDA, the first loop ABDA, I'll write, the first one is the voltage drop, 100 ohm resistor, current is I1, so I'll write 100 I1, I'll write 100 I1, then I'll move in this direction. In B to D, I'm moving also in the direction of current, and I'm getting a resistor 15 ohm, so I'll write here also negative, here also I'll write negative 15 IZ, I'll write. Then I'll move here. When I'll move D to A in this direction, then you can see there you are moving against the current, because current I2 is flowing downward, you are moving against the current. That's why here I'll write plus 60 I2 is flowing here. All the voltage, change in voltage, this is I2. So here you can see resistor into current, I into R is equal to voltage, from Ohm's law we know that, is equal to 0. All the changes in a loop is 0, changes in the potential difference. So here I can take 5 common, I can reduce this equation to a smaller equation. So it will be, if I'll divide 5 with each term, I'll get minus 20 I1, minus 20 I1, minus 3 IZ, plus 15. 12, 5, we are dividing with 5, so 12 5 is 16, 12 I2 is equal to 0. So this is the first equation I got. Now I'll proceed to the second loop. So in the second loop, you can see I am moving in this direction, so I am getting the current here. So you can do this, like you can write this one, I'm moving from B to C, I'm moving along with the current, so I can write this loop as BC DB. So for this loop I'll write minus 10 into I1 minus IZ, so 10 I1, I'm just writing explicitly, minus 10 I1, minus plus 10 IZ, then I2 plus IZ, C to D, but it is in opposite direction, so I'll write it plus 5 into I2 plus IG, so it will be 5 I2 plus 5 IZ, then I'll move again on D to C, again I will move against the current, so it will be also plus 15 IZ is equal to 0, or if I'll write it in a reduced or simpler form, this is I1, only one I1 is there, so I'll write minus 10 I1 minus 10 I1 IZ 15 5 20 30 IZ 30 IZ, then 5 I2 plus 5 I2 is equal to 0. Here also I can reduce it. I can divide this with 5. Here also I can divide this with 5. So if I divide it, it will become minus 2I1 plus 6 IZ plus I2. Just after this last equation, what we'll do, we'll use simple equation solve technique that you have already learned in class, your high school classes, that substitution, elimination, cross multiplication, or using these techniques you can solve I1, I2 and IZ. So this is your second equation. Now we'll go for the third equation. In the third loop, as I have told you, the bottom one, that is the loop we'll write for ADCEA. ADCEA. So in this loop, what will be the equation? 60 I2 minus, obviously because we are moving along the direction, here also we are moving along the direction, so I'll write minus 5 I2 minus 5 IZ, then I'll get a plus 10, because when the cell is there, we generally start from the cell, so we are moving along with the direction of the cell, so I'll write plus 10 is equal to 0. So now again let me simplify this one a little bit. So here also this is I2, so 60 I2 minus 5 I2, this is minus 65 I2 minus 5 IZ plus 10 is equal to 0, or you can say this is minus 13 I2 minus Iz plus 2 is equal to 0. So this is equation third, you can say. Now this is three equation in your hand. You can solve this three equation and find out first Iz you can find out. So how will you do this? You can see equation 1 and 2. So if we'll multiply 10 in equation 2, what will happen? And subtract from equation 1. So you can do these combinations. So equation, let me write equation 1. Equation, this is equation suppose 1. So equation 1, this is minus 20 I1 minus 3 Iz plus 12 I2 is equal to 0. Now equation 2, I'll multiply 10 into equation 2. I'll multiply 10 with equation 2. So what will happen? If we'll multiply 10 with equation 2, then you can see this will become minus 20 I1 plus 60 Iz plus 10 I2 is equal to 0. Now I will subtract it. So this minus will become plus, plus will become minus, minus. Okay. So when I'll subtract it, I'll get this one. Minus 20 plus 20 cancelled. This one will become minus 63 Iz. This will become plus 2 I2 is equal to 0. Let's say this is equation 4. So now it's a two variable equation, and here also equation third is a two variable equation with I2 and Iz. So now we can solve easily and you can get the value of Iz. So if we'll simplify equation 3, we'll get Iz is equal to I2, you will get, just let me write, minus 13 I2 is equal to Iz minus 2. Okay, now you can write it that I2 equal to Iz minus 2 by minus 13. Now I'll put this value in equation 4 and I'll calculate Iz. So I'll put here in the equation, that is minus 63iz plus 2i2. I2 I am getting this one. So 2 into I2 I am getting as, this is Iz minus 2 by minus 13 equal to 0. Now you see this two variable equation converted to one variable equation. From here you can easily calculate Iz. So this will become LCM 13, so it will become minus 13 into minus 63 Iz plus 2 Iz minus 4 equal to 0 by minus 13. So it will cross multiply minus 13, it will become 0. Now what will be the solution? So the solution will be minus 13 into 63, so it will be 39 81 Iz plus 2 Iz is equal to 4, or Iz is equal to 4 by 821. So you divide and you find out this much of ampere. Okay, 4 by 821, approximately it will come in some milliampere Iz. So this is the current Iz that flows through the BD, this current. Now you can also put the value of Iz in equation 3, and you can calculate I2, and you can put I2, the value of I2 and Iz in either equation 1 or 2, and you can find out I1. So I1, I2, Iz, all the three values you can calculate. All the three values you can calculate, and you can solve by solving the three equations. So this is one application. This example we discussed about the application of your Western Kirchhoff's law in a Western bridge. We have used both the junction rule and loop rule of the Kirchhoff's rules here. So you can solve many questions for different competitive examination and other examination. Okay, so thank you. We'll discuss some other question in the next class. Thank you.